So here, what we're looking at is section 2.2. This is section 2.2, and here, what we're looking at are graphs. Basically, what we're going to look at is the graph. We're going to look at equations in two variables. So before, we had equations in one variable, okay? Just one variable, I think, which was x. Now, we're going to kick it up a notch and look at equations in x and y, two variables. We're going to see those, and we're actually going to see their graphs. What does it mean to say the graph of an equation in two variables? What does that actually mean? We're going to see that today. Not only that, okay, what we're also going to see is certain specific graphs. Like, for instance, we'll see the parabola. You might have seen that before. And we're also going to see the circle. Yeah? Good. All right. Anyway, what is a graph exactly? Like, what's the formal definition of a graph? Well, a graph is just a collection of plotted points in the Cartesian plane. That's all it is by definition. So for instance, this is a graph I have, right? I just plotted one point. That's a graph. I mean, is it an interesting graph? Probably not, but it's still technically a graph. Okay. Now, there is a connection with equations in the variables x and y. So if you have an equation that is in x and y, okay, just like we had equations in one variable, we have an equation in two variables. We can ask what their solution is, and that's what I'm defining here. Since we have two variables now, solutions are not going to be just single numbers. They're going to be ordered pairs of numbers. The whole idea is if you have an equation in x and y in two variables, a solution is an ordered pair of numbers where AB, where if you replace x with A, sorry, let me say that correctly. If you substitute A in for x and B in for y, so if you substitute the x coordinate in for A and the y coordinate and B into the y coordinate B in for y, you get a true statement. Remember, equations can be true or false. So here's an example I give. We have y equals 2x minus 1. Okay, well, let's look at the ordered pair 2, 3. Is this a solution? Well, it looks like it is, because if we replace y with 3, if we substitute 3 into y, 2 into x, we have this. And we have 3, is that equal to 2 times 2 minus 1? Well, yeah, this is 3 equals 4 minus 1. That's true. So this is a solution. What about this point, 1, 3? Well, it's not a solution, but why? Well, if we substitute 3 in, 3 is the y coordinate, if we substitute 3 in for y and 1 in for x, is this a true statement, this equation? Here we have 3, we have 2 minus 1, which is 1. So no, it's a false statement. So this is not a solution to this equation. I also checked the origin, 0, 0. It's also not a solution. Here we would substitute 0 in for x and 0 into y, but you would get 0 equals negative 1, which is a false statement. So the only solution we see here is 2, 3. But in fact, it's actually very easy to get many solutions. The whole idea is you just replace x by different numbers, and then you calculate the corresponding y. You replace x by numbers where the right side makes sense, or the left side, that is. And you can calculate according to y. That's what I'm doing here. We have -1 we plugged in. We calculate the corresponding y. So we get this is a solution, I guess, by construction, so to say. Mostly because this calculation shows that this satisfies this equation. If you replace x by -1 by calculation, y equals -3, and y by -3, you get a true statement. Same thing here. If we let x be 0, we calculate y, which is -1, so that the equation is true. So this is a solution. Same thing over here. And of course, you can actually do this for infinitely many values. Mostly because you could replace x here by any number you want. You know, if you do 2 times that and subtract 1, you'll get a number that makes sense. And that brings us to the graph of an equation. In other words, the graph of an equation in x and y is just a plot of all its solutions. So that's actually what you're looking at. When you sketch the graph of an equation, what you're really doing is you're plotting all the solutions to the equation, all ordered pairs that are solutions to the equation. I did list here how you would actually do that. I mean, with calculators and technology today, you can get better graphs, but being able to plot by hand is a good thing to do. Now, you don't want to rely entirely on technology. You want to still be able to think and understand what's going on. So basically, I wrote here how you make the sketch of a graph, how you would sketch the graph of an equation in 2 variables. You know, you could do something like this. You make a table, although you probably would want to use as many x values as you can, as feasible. You would plot the corresponding solutions, the ordered pairs here, in the Cartesian plane. Then you want to connect. You connect the points by a smooth curve. Smooth meaning it has no like sharp turns or something. Here, let me see if I can draw that. Let me see if I can. You know, smooth meaning it's not like this, like a point, like quick turn. Of course, the more points you draw, the more, points you plot, the more accurate your graph's going to be. Just to help illustrate that, let's consider this here. Y equals, this should be -x plus 2. Why do I, Okay, so something's not right there. Should be 2x minus 1. Okay, so these are right, but this graph, unfortunately, is wrong. So, but here, let me fix that. I missed that. I guess I didn't think I would get this far, and this mistake I would have caught. So this is what we're graphing. Well, this is we wanted to sketch the graph of that. So unfortunately, this graph is wrong. Well, I guess that's okay. Anyway, this is how you would graph it, though. I mean, the graph's wrong, but the idea is you would actually, pick x values, plug in the corresponding x values, get the y values. Then, okay, you would calculate the corresponding ordered pairs. You would plot those pairs, right? And that's how you would get your graph. I mean, you're not going to get this. I'm not sure why this is here. That was my fault. So sorry about that. Let's see. Okay. What you actually would get is a straight line, and it would pass through this point. It would pass through each of these 3 points. So, all right. Let me just quickly we'll start. I'm probably going to start with this example next time, but I'll have the right graph on the slide. But let me just say this. Here, we have these notions of the x-intercept and the y-intercept. I mean, there is a formal definition here. I'll go through this again next time. But let me just say, though, that the x-intercept, that's just where the graph crosses, or excuse me, touches the x-axis. Hence the name x-intercept. For the y-intercept, okay, for the y-intercept, that's where the graph intersects the y-coordinate. Okay. All right, we have about a minute left, I think. Yeah, we're actually almost out of time. So let me stop here. I'll start from the, what do you call it, this example next time. So not sure why. I don't know. I messed up there. I'm really sorry about that. We'll start from there next time though. So let's call it, we'll stop now.